All right, it looks like we're live. So hello and welcome to the 2021 UAF Arctic Innovation Competition presented by UC Coal Mine. My name is Ashley Plies and I'm a UAF School of Management student studying accounting, as well as an AIC team member. I'm so excited to be your MC tonight and for this first ever virtual AIC. We appreciate all of the creative ideas that are submitted to AIC, but after a round of preliminary screening, only 10 have made it to the main division semifinals for ages 18 and over. Tonight, you hear 5 of those top ideas. The main division semifinalists are competing for cash prizes from $100 to $10,000. I want to let our competitors and anyone watching on the live stream know that we are recording each of the semifinal sessions this week, and you can find them on the AIC webpage. Our streaming platform does not allow us to show you the slides, but more importantly, if you're watching online, you'll see and hear the competitors. Tonight, we would like to introduce our expert panel of judges joining us tonight. Please make sure you have your cameras on, and we'll start with John Bittner from the Alaska Small Business Development Center.
Hello there.
Jim Cully representing Mount McKinley Bank.
Hello.
Reggie Dallaire from PDC Engineers and a 2014 AIC Arctic Kicker winner.
Hello, good evening.
Catherine Dodge is a special projects manager for her own consulting firm.
Hi, welcome, good luck.
Brian Holst is hailing from Juneau Economic Development Council.
Good evening from Juneau.
Kathleen Hook is representing Doyon Utilities.
Good evening from North Pole. Good luck, everyone.
And Jack Wilbur, our judge's chair, is from Design Alaska.
Good evening and good luck.
Thank you, judges. And let's get started with presentations. Each competitor has 5 minutes to present their ideas, followed by 7 minutes of questions from our judges panel. Competitors, please remember to say next slide when you are ready for us to advance to the next slide, and keep an eye on your timer to see how much time is left. A familiar name is up first tonight, Robert Werner, who received a 2019 AIC honorable mention. Robert claims to be an ideas kind of guy, and we believe him because 2 of his ideas made it to the AIC semifinals. Robert has set a great example and showed us that you can enter AIC more than once. Tonight, Robert presents his idea, Toast Test for COVID aerosol modeling. Robert, can you see your slides?
Yep, I can.
You can?
Yep.
Perfect. All right, just give us a thumbs up when you're ready to start.
All set. Thanks a lot to the Arctic Innovation Competition for allowing me to present the Toast Test for COVID aerosol modeling. Next slide, please. Next slide. Oh, thanks. This is the picture in the center is a COVID computer simulation of COVID-19 aerosol cloud, which is how it brings to mind, how can you pack hundreds of people in a plane without causing the spread of COVID? This in spite of breaking every guideline, no distancing, no barriers. Well, easy. On most planes, the air exchange rate is approximately once every 3 minutes, and 75% of it comes from outside the plane. So how do you make sure that the hotel, bar, or restaurant that you're in has the same level of safety? And the trick is to design a testing system for these places that measures if ventilation and filtration are adequate. Next slide, please. This is a practical way, the Toast Test is a practical way to evaluate work and entertainment spaces. Currently, there are a multitude of CDC rules and guidelines for the operation to mitigate virus transmission. But a short conversation with an infected asymptomatic super spreader talking at a normal volume yields about 6,000 aerosol particles in 10 minutes. This cloud is made up of particles all smaller than 2.5 microns and can stay suspended and infectious for many hours. There's currently no objective standard for testing indoor spaces for virus transmission. You need a test that basically responds to HEPA air filtration, ventilating fans, or air exchanges with the outside air, but doesn't involve infectious material. Next slide, please. Basically, the toast test uses smoke particles that simulate the movement properties of a viral cloud. They're about the same size, easy to measure, and harmless. The smoke cloud responds to the same HEPA filtration ventilation efforts as a virus, making the study of these effects easy to study in any building, vehicle, or outdoor area. The bottom right shows a diagram of how the sensor works. You have a nostril that provides input and one nostril that provides output of the outside air. A laser on the inside using an algorithm counts the number of particles. Next slide, please. You can click this again to start the video. The toast test involves 2 slices of toast that are placed in a conventional toaster. Fire alarms are disabled. The toast tester is activated and placed next to the toaster. The toaster is placed on high and started. The toast tester will signal when the PM 2.5 levels have gone over 1,000 to activate the testing scenario. The toast tester will tell you when the levels have reached a minimum level, and data is shared on an iPhone app. Next slide, please. This shows the output of a toast tester. The blue is the actual levels of the particles, and the green is actually integration function that tells the integration of the level over time. So a flat plateau is a real good sign. You can see on the left why nobody gets infected in the outside air. It's a diagram of how fast the particles dissipate, usually within about 8 seconds. You can see bottom right, a closed room, only 500 cubic feet. It just plateaus out and the particles stay there basically suspended forever. You can see what happens when the door is open. And then finally, 7,200 cubic foot room, 80% diminution in 5 minutes as the smoke cloud slowly clears over time. Next slide, please. Building the toast tester, it involves just a plan tower sensor, a well-studied and accurate device, small battery, a microcontroller, and a NeoPixel bar, which changes colors. Next slide. The units are designed in Fusion 360. They're 3D printed. The approximate cost is only about $50, and you can actually have several networked that'll tell you the distribution of the cloud. Next slide. This is the output screen. The current level is on the top there. 2 screens will tell you the speed of diminution of the cloud. Bottom level tells you your peak level, and the buttons are involved in sending the information to the internet. Next slide, please. This is what the output looks like on your app. The app is designed to show particle level over time. You can see on the bottom right, the actual NeoPixels, it changes color as the different levels appear. And that's it.
Thank you so much, Robert. Are you ready for some questions from our judges?
Yeah.
All right, so judges get to ask questions in a particular order. Once we stop once we hit the 7-minute mark, and the next round of questions will start with the next judge on the list. Tammy will help with moderation, but we will begin with Jack, Kathleen, and Jim, and then it's open to the rest of the panel.
So what is I know that the toaster is essentially creating particles that are being measured, but really what is the toaster representing in human form? And
it's a good question. The viral particles seem to occur at the same size as the smoke particles. They occur in a plume, usually between 2.5 microns and the actual size of the virus particle, which is 0.1 microns. And they tend to float just like the smoke particles do. So the smoke produced by the toaster emulates basically the types of particles that are found with the COVID.
But is the size of the cloud and the number of particles created by the toaster, how many people does that represent? Is it a single person?
It's a good question. You're not, the test really doesn't measure that. It measures the dispersal of a type of cloud that would be similar to one produced by a human. It's not so much that you're curious about how many people would be involved, but each room would have a unique dispersal pattern, and you want to see how fast a cloud of that type disperses. Same way as an airplane, you would test it with one dispersal cloud and see how fast it goes.
How far away is the sensor from the toaster when you're
Real
doing
close.
this test? Huh?
Yeah, you're real close. It's right above it, basically. You just want a load of particles, and then you want to see how fast it disperses. After the toaster pops, actually, it produces no more particles.
Thank you.
So, your monitor is right above the toaster, and so you're monitoring the particles. I guess I'm struggling with a couple things. One is that you had the coronavirus at everything from 0.1 to 2.5. I would think a particle at 0.1 would act very different than a 2.5 micron particle. And you're saying it doesn't?
Strangely enough, it doesn't. This is one of these still at the infancy stage in terms of they didn't really understand actually in March that this is an aerosolized particle problem rather than one that's produced by big clumps. They used to think that this COVID was actually transmitted by large particles like 10 microns and above. But they rapidly found out that those kind of particles actually fall to the ground very fast and disappear.
Right.
Go ahead.
Right. So that would be my point, is that a 2.5 would fall out. It would have more weight to it than a 0.1 that might stay aerialized more. And so that a 2.5 particle may not be representative.
Actually, they found that 2.5 millimeter particles are typical for these kind of viruses in terms of their spread. They've studied them with influenza and several other viruses in prior times, and they found that basically they are in these size particles. So the dispersal rates are kind of the same, and they tend to hang for hours, unlike larger particles, which kind of physically just fall down.
Sure. And so then you created those graphs you had your monitor station, whatever, right at the toaster, and your graphs were created over time, just right there.
Exactly, yeah. They're kind of interesting, actually, the integral functions. And you can see them right there on your phone on the app. You can just see how fast your room kind of changes. But it's surprising. I actually tried some other things using the HEPA filters, for example. I borrowed a friend's HEPA filter. It has very little effect over time, even a good one. Surprisingly, just opening a window, boy, that's substantial in terms of clearing of the virus particles. It surprises you. I'm sure some restaurants and places, the virus load will just stay steady. Even though they have good.
Well, I think we're seeing that with PM 2.5 here in Fairbanks and North Pole. It's how it moves through the community. Thank you, Robert.
Thanks.
So Robert, a couple of questions. So one, it sounds like you're holding this right over the source and then measuring it there. Wouldn't the object more be to have multiples of these and measure at different locations in a room so that you could see how the cloud dispersed? Whereas instead of just staying in one place, I would think that would be more useful than just measuring it right at the source.
Totally a good idea. That I suggested that you have multiple of these units collected by Bluetooth, and they would report to the same app on the phone, and you could physically describe and find out where you're holding particles and where you're leaking particles. This thing would give a three-dimensional view, and you're totally right on that.
Okay, that was kind of my question. Thanks.
Okay, we have a time for one or two more questions, so please raise your digital hand or your actual hand, judges. All right, Reggie Dallaire, you're up first, please.
Robert, quick question. How real time is this? Could you walk around a room with this and measure particulate matter and look at it on your phone at the same time?
Totally, yeah. It's a real neat system. You can just watch it just rapidly descend or plateau out. I haven't tried this at too many locations, but my belief would be that it would be really interesting, actually.
All
I agree with Jim. I'd like to see a network of these across the room, and then you'd be able to map how the particulate moves through a room.
Yeah, it's easy to do with Bluetooth, and in terms of the cost of these units, they're not that expensive.
All right, Jack Wilbur is going to finish us up with his question.
So just kind of a fun question. Where did you find a sensor that looks so much like a dog's nose?
I designed it in Fusion 3. I thought this will make it homey, something so it'd be neat. And I loved it the way the one nostril takes the air in and one blows it out. You can actually watch the smoke go through the sensor that way. It's really kind of fun.
That was pretty neat.
Thank you, Robert and judges. We are going to pull our second presenter in here and give the judges a little bit of time. So one moment. All right, our second presenter this evening is Katrina Howe, explaining the idea with the longest name, Count on Me, Home Office Technology Supporting Health and Productivity. All right, can you see your slides, Katrina?
Yes, I can.
Perfect. Remember to keep an eye on your timer and give us a thumbs up when you're ready.
Next slide, please. My name is Katrina Howe, and I am a senior at the University of Alaska Fairbanks. Next slide, please. When COVID hit, millions of people worldwide had to work from home. They set up workspaces where they could, often with whatever was to hand. Home offices pose some problems. Working alone means there are few external cues for taking breaks, and breaks are vital to maintaining productivity. Working away from time clocks and such often means you need to track your working hours yourself. In a corporate setting, there are usually people assigned to ensure your workspace is set up ergonomically. Next slide, please. Merriam-Webster defines ergonomics as an applied science concerned with designing and arranging things people use so that the people and things interact most efficiently and safely. It was with all these things in mind that I designed Count on Me. Next slide, please. Count on Me is a time management software with a customizable keypad, which also includes a handout for healthy home office practices. Next slide, please. The software includes timers that count up how much time has been spent on a project, timers that count down to bring you back from a break, and allows you to keep track of tallies, such as how many liters of water you've had today. This data can be exported as comma-separated values and shown as graphs. The software comes with several preset timers and also allows you to create custom ones. It also allows you to customize the keypad, which I'll speak more on in a moment. Upon startup each day, the software will give you a health fact of the day to help you improve your workspace and health habits. Next slide, please. The hardware is a keypad that acts as a tactile interface to make muscle memory work for you, so you can switch tasks without interrupting your workflow. Using the software, you can assign each of these keys to either be associated with count up timers, count down timers, or tally counters. The keypad will also be compatible with the powerful timekeeping software Office Time. Next slide, please. The keypads will come with pre-printed labels and blank labels. Users can choose between pre-printed words or symbols, or write their own labels. In this slide, you can see 3 examples of customized keypad layouts, including one with custom labels. Next slide, please. Foundation Health Partners graciously allowed me to use the reference sheet for home office health. This includes information on setting up your workspace ergonomically, as well as various stretches that can help keep the body loose instead of getting all balled up at your desk. Next slide, please. I would like to thank Foundation Health Partners for allowing me to use the reference sheet, and to thank Productive Monkey Limited for allowing me to use office time and advising me on my software. And thank you for your kind attention today.
All right, thank you, Katrina. We're now going to switch over to our judges panel to see what questions they have. We're going to start with John, Reggie, and Catherine.
Thank you.
Hi, Katrina. Sorry, this is a really interesting project. I didn't understand the key. I'm glad you have one because I didn't get what you were talking about until you held it up there. I was like, oh, it's actually a physical mechanical keyboard. So on your labels, it just said time up, count down. Could you program each of those buttons for a specific project? Like say I'm a web developer working on 9 different consultation projects. When I switch over, can I just tap the button and it tracks my time sequentially like that?
Yes. So in the slide where it showed, actually, I should be able to show you now, the different assignments for the keys, here you go. You can see how I have, these keys are the count up timers, these keys are the countdown timers, these ones are the tallies. And so then that's the programming side of it. And so then each of those are associated with different timers that you can create labels for. And then you can create your custom paper labels that actually slip in underneath the keys actually have a little cap. And you can slip your paper in there so that you know what this one is for. The program knows it's a count up timer, and you know that you're counting up project 1 programming for so-and-so company.
And every time, so if I hit project 1, I do 5 minutes, and then I move over to project 2, 5 minutes, and then I move back to project 1. Does it go for 5 minutes and keep going, or does it start over every time?
It keeps going.
Awesome.
So
wow,
yeah, so
really,
it accrues
cool.
over time. Yes, exactly. So that you can really easily switch between tasks without having to worry about adding it up. The computer adds it for you.
Excellent. Thank you so much.
Thank you.
I guess I'm up, Katrina. So quick question. So why the keypad? Couldn't you just do this with virtual on the screen buttons and you could make them anything you want? You wouldn't have to slip a piece of paper under a keypad. You could just type in a new name, right?
Yeah, I'm so glad you asked that. There's 2 reasons. One is that when you have a physical keyboard that's beside your usual keyboard where you're typing all the time, it's easy to just reach over and click a button, which eventually your muscles will memorize for you. So you won't even have to hardly think about switching tasks like that. And so it keeps you from having to minimize your screen, maximize another one, click, and then maximize again. Instead, you can just easily just click a button and it goes on to the next project. And then the reason why I'm using a wired keyboard is that there is a design, there's actually a couple designs that are Bluetooth that are tactile interfaces, but they've had syncing issues. And so people have lost their time, and that's billable hours, that's money. And so having it wired allows you to have a stable connection and no problem. You've got your time right there.
Okay, no, I get that. And so the part that you've built is the keypad, right? And now, did you develop any of the software, or that's off the shelf?
I am also designing software. I'm making my keyboard so that it works with Office Time, because Office Time has really robust system for counting up timers, but it doesn't have any countdown timers, and you can't count tallies. And so my software can do counting up and has comma separated values, but it doesn't have some of the invoicing that Office Time has. But it can work, you can work with both of them to, so that if you choose to have Office Time doing your count up timers, it can do that. And then my software can handle the countdown timers. Or if you don't want to have Office Time, it'll handle also the counting up timers.
Thank you.
Thank you.
Hi, Katrina. So my question is about one of the things that I thought was really exciting about this project was being able to auto-populate a form or something of that nature. Can you, you're having CSVs as your output.
Yes.
Do you have an interface to Excel or to Google Sheets or anything of that nature, or is there an import? You know, how seamless is that, or how easy is that?
Yeah, it's just it'll export the file into a CSV like you noted, and then you'll just import it yourself into Excel or worksheet of choice.
Okay. And how easy is it to assign these values? I mean, how the up count, count up, count down. Where do I do that? How easy is it?
Yeah, that is really simple because there's a screen where you can customize the board, and it has it laid out. So you know this is the top of the board, this is the bottom of the board, and then you select each key, label it with whatever you want. This key is for Zoom call. And then you select if it's count up, count down, whatever kind it is. With a Zoom call, probably you're tracking how much time you've been on a Zoom call. So that would be a count up timer.
Okay, thank you.
Thank you.
All right, it looks like we have time for a question or two. Hands up, please. Digital hand or real hand. I see Brian first. Brian, would you please like to ask your question?
Yeah, this is a really practical tool. Thank you. So
Thank you.
can you explain a little bit better what the real differences are between the Bluetooth versus the wired? Is it just the wire, or are there some additional improvements that you've made?
That's a good question. Basically, it just comes down to it being a really stable product. That the Bluetooth, Bluetooth is nice, but it would drop out sometimes, and so you don't want to have to be dependent on this other signal. So it just has to do with how it reads directly into the computer. There's no possible way of interrupting that signal, so it's steady.
All right, do we have one last question, or do we want to? All right, Kathleen will be our last question for today for Katrina.
So Katrina, what's your next step with this? What do you hope to do with this?
I'm glad you asked. I am speaking to programmers now. We're working on the software. I have started designing the hardware, and I'm in talks with a manufacturer in Maine for rolling these out. And I am hoping to start a Kickstarter at the end of May. Thank you.
Thank you so much, Katrina. Before our next presenter, we are welcoming you to our first sponsor spotlight. There are special $2,000 kicker prizes up for grabs for any of the top 10 main division ideas, regardless of where they place in the finals. That means these kickers could go to an honorable mention or the $10,000 grand prize winner, or anywhere in between. The Arctic Kicker is a $2,000 prize sponsored by PDC Engineering. Although AIC ideas do not have to be Arctic in nature, they often are because of our geographic climate. This special prize recognizes a new innovation that is sustainable, efficient, and makes living in the Arctic easier. The Alaska College Student Kicker is a $2,000 prize sponsored by Mount McKinley Bank, one of our new sponsors to AIC. This special prize is given to the best idea submitted from any Alaska college student currently enrolled at any university in Alaska. Thank you, PDC engineers and Mount McKinley Bank, for your support of innovation and the entrepreneurial spirit. Real quick, we're going to bring our next presenter in. Let's give Zoom some time to load up. All right, our next presenter is Luke Millam, explaining the idea reinforced ice with partially entangled hemp fibers. Luke, can you see your slides?
Yes, I can.
Perfect, just give us a thumbs up when you're ready.
All right, my name is Luke Milne, and I'll be discussing ice reinforced with partially entangled hemp fibers. I've been studying ice reinforced with hemp for the past 3 years. Next slide, please. Now, with normal ice reinforcement methods, most notably is pykrete, it is very hard to get an even distribution of the fibrous material through the entire ice beam or ice structure. And this causes cracks to try and find the weakest path throughout the ice beam, which leads to reduced strength and makes it very hard to find design values for the ice structure. Next slide, please. Now, to combat this problem, I've used hemp, which is very strong biodegradable fiber and is normally used for rope and twines. Now, first, hemp is very clumped up and hard to work with. So you must remove the hemp hurds and break up the clumps with a nail board, which separates the fibers. Next slide, please. Now with the fluffier, less compact hemp, you alternate general fiber patterns in transverse and longitudinal directions based on which way they were separated. Water is poured onto the fibers, and then they are compressed and agitated. I used a sander without the sandpaper on it. Then they are left out to dry. Next slide, please. So once you're done, you get a hemp mat. So I have one here. Now it's very easy to roll up and transport, and makes it a lot easier to distribute the hemp fibers across an ice road or an ice structure. I currently have a provisional patent on partially entangled hemp fibers and other fibrous materials reinforcing ice. Next slide, please. Now I've conducted lots of strength testing. With this large ice beam, it was 10 feet long over a 9-foot span, with only the bottom 2 inches of the ice beam being reinforced with hemp, and it's total 8 inches thick. It was loaded with 40-pound bags of water softener salt, and a load cell was used to record the strength of the ice beam, or the load it was supporting. Next slide, please. Next slide, please. Could I get the next slide, please?
I think she's trying. She looks like she's focusing there.
Oh, he can want the next slide all he wants, but we can't hear him. Is it just me?
All right, so with just 4.2 pounds of hemp added to the 350-pound ice beam, the capacity of the ice beam was increased all the way from 180 pounds all the way to 2,100 pounds. Next slide, please. Now, I conducted a finite element analysis model, and the results from the large ice beam were held similar moments to the to my ice bridge design. Next slide, please. All right, this is for an HS20 loading, which is a 70,000-pound truck with a safety factor of 2. Next slide, please. Now in Canada, there's a 250-mile ice road, which is 85% over lakes, and very notably is an ice road in to Tanana Village, which is a $14 million road, but it ends at the Yukon River. Now to cross the Yukon River each winter, an ice bridge must be created. And I estimate by reinforcing the ice road with hemp fibers, you could, with 50 tons of hemp, which is $5,000 plus shipping costs and entangling costs, it could be reduced the time of construction by 3 weeks. Next slide, please. Now, with the 2018 Cannabis Act in Canada and the United States 2018 Farm Bill, the regulations on hemp creation are being reduced or were reduced. This allowed 92,500 acres of hemp grown in Canada, and this is approximately 1,300 pounds per acre of hemp fibers. Hemp is mostly grown for hemp seed and CBD oil, which leaves an excess of hemp fibers looking for new markets. Now, by creating a local demand of hemp fiber in Alaska, could spur the hemp industry in Alaska and other Arctic regions. So for my next steps, I would want to do a large-scale testing of a full-scale ice bridge to make sure my design values hold true at a larger scale. And I would like to create a machine for large-scale entangling machine that could be used to mass produce partially entangled hemp fibers. Thank you.
All right, thank you, Luke. You did great, even with unforeseen technological issues. We're now going to go to our judges panel for questions about your reinforced ice. We're going to begin with Brian, Jack, and Kathleen.
Wow, that is so amazing. Blew my mind when I saw that and saw your video. So yeah, great thinking. So my question is not about the ice, though. I'm sure you've got some great thoughts about how much weight you can carry and whatnot. Is what happens to this, say you put it over a river and it melts. What happens to the hemp and our, and our rivers, and what environmental concerns might we have with this melting? Thank you.
Okay, so hemp is biodegradable in its natural fibrous form. Now, I stayed away from ropes and weaves specifically for this problem, as it would be very hard to get them out of the river, and it's also wouldn't be as well distributed. But I do not know the impact of normal hemp fibers, but I do know that by partially entangling the hemp fibers, you wouldn't further endanger the environment, because in water, the partially entangled hemp fibers breaks apart naturally on its own and turns into like normal hemp fibers very quickly. I tested this by putting it in a bucket and swirling it around a little bit, and it just fell apart very quickly.
Yes, a couple questions. So you mentioned the road to Tanana, and I think that's a great application for something like this. Are there other locations in Alaska you think that could use this too? I mean, what about on the North Slope where they're building roads to drilling pads and things like that?
Yeah, so there are very many ice roads created each year in Alaska and Canada. It's a big one, especially with the 250-mile ice road. Now, I do know of Bettles Village is another village in Alaska that needs an ice road to reach it each year. And also the Blair Lake Impact Range at Eielson Air Force Base would be a good starting point to try out an ice bridge design.
And so it's already been talked about environmental impact. Have you approached, I'm not sure what governmental agency you would have to contact, or EPA or DEC or whoever, but have you approached any of these agencies with this idea and kind of at least gotten a first blush from them on what they think about it from an environmental standpoint?
No, I've not approached an environmental agency. I did approach I guess the person from Eielson Air Force Base, and they're very interested in this idea. But yeah, I haven't approached anybody specifically for environmental impact.
Thank you.
Yeah, this is very interesting, Luke. There are many ice roads. It is a biodegradable material. I would be concerned biodegradable, though, at 40 degrees is different than 80 degrees. And so what would accumulate in the environment if you built this ice road over the years? So I think that would be a good step to talk to DNR and DEC on if it was water or state land. I guess what are you seeing as your next steps here with this great idea?
So definitely, I guess big next steps are full-scale testing to make sure my design values at a small scale represent the same at a larger scale with two-plate bending. And researching the environmental impact is also huge, and making sure I can get permission to test the idea and actually use it in the waterways. And then creating a large-scale entangling procedure that could entangle the hemp fibers, because currently it's very time consuming and hard to do.
Thank you.
All right, let's open it up to the panel with your digital hand or your real hand. And John Bittner was first up, followed by Catherine Dodge.
So first off, Luke, I just want to commend you. It's not easy to give a presentation, have something go squirrely halfway through, and then recover as well as you did. So that's really, it's truly impressive. Well done. The other thing I wanted to ask is, I can definitely see the application in road systems, things like that. The mat itself looks kind of interesting. I mean, the fact that you can get those entangled fibers to mat up like that, roll them up and use them. Have you considered, are there other applications for that product beyond just ice roads?
Yes. So I've one thing I was thinking of is ice like sculptures, and because it's very popular to have like ice buildings, so it could potentially reinforce the ice and make it easier to build with. So like ice fishing huts are like very small scale building too. It could be kind of like a quick, cool feature. Floating barges in the kind of in the Arctic region could also be used as kind of like a landing pad for like helicopters or something on water as a floating structure. But I've not researched any of these ideas.
That's great. Thank you.
So, Luke, I'm curious about learning more about the large scale detangling machine that you want, because that did look like a expensive thing.
So it's very similar to current felting methods used for like wool, and so by you could transition a lot of those current like large scale methods into the same processes for hemp.
Okay.
So you could kind of recycle a lot of the felting process and move it toward hemp, but it wouldn't. There would definitely need to be some alterations and changes.
So it sounds like that could be another invention that could have a lot of uses too. Actually. Yeah.
Yes, and I would like to make it compatible with the current. So there's a current machine that basically moves hemp fibers through it, puts it into the raw hemp fiber form, and I'd basically want to be able to take that raw hemp fiber and make it directly into partially entangled hemp.
Thank you.
Quick question. Have you considered the traction value? I mean, it seems like it's inverted now where the hemp is at the bottom. If the hemp is at the top, I don't know if it changes the strength of the ice, but would it be by being exposed slightly? Would that provide some additional way of traction for vehicles?
By exposing the hemp fibers on the top of the ice road.
Right.
So I like honestly, I think one thing is you have to make sure the like trucks would have to be going slowly, especially at like high weights over these ice roads. So it wouldn't provide much impact on an ice bridge over running water, but it could provide impact over ice roads over tundra and other like normal roads. So that could.
Thank you.
All right, thank you, Luke. We are going to bring our fourth presenter in, so hold a minute. All right, so our fourth presenter this evening has the idea air gap geodesic domes made from recycled plastics. And this is Crystal Hoke. All right, Crystal, can you see your slides?
I can, yes.
All right, just give us a thumbs up when you're ready and watch your countdown clock.
Good evening, everybody. My name is Crystal Hoke, and I am involved with several community organizations in Girdwood. And thank you for letting geodesic dome gardening idea made from recycled plastics. Next slide, please. One of the organizations that I work with has invested in building these machines that you're seeing behind that text there. This gentleman's name is Dave Hawkinson. He's a European designer, and he's been working on solving the plastic waste problem. And what he does is he open sources these blueprints to build these machines. And they're kind of common materials. He tries to make them as basic as possible, so anybody in Africa to Alaska could source the materials. And so I really think that he plays a big part in how this problem is going to be addressed. He's certainly been an inspiration of mine, and I've been following his project for a couple of years, and it's now to a stage of development that I really want to use this concept and then expand upon it in something that would work in an Arctic environment. Next slide, please. So what you're seeing here are some of the products that he's already created, and many people have already created. One of them is a brick wall that's built from recycled plastic bricks. The mold, the plastic brick mold there is in the middle. The picture on the right is basically a piece of artwork, a basket that's been created using the recycled plastic, and behind him are sheets of plastic. And so those are just some products. There's a lot more that have been created, but just showing you that this has already occurred and is actually happening worldwide. Next slide, please. So these are some of the custom molds. Here you would see one that has already been used as an example for a geodesic dome connector. What I want to do is make a geodesic dome that's specifically for an Arctic environment to extend our growing season. So I would either be purchasing some of these molds that are available or having a welder build a custom mold. Next slide, please. So I read that the highest R value from an air gap is 30 millimeters. So what I'm wanting to do is create a geodesic dome with a 30 millimeter air gap between. So it's using the simple technology to insulate the dome. And so basically creating a dome within a dome, 2 layers of plastic, creating that air gap in between. Next slide, please. This project works to solve 2 issues, the plastic waste problem, which is huge and massive and can't be tackled by one person or one company, and needs to be utilized in a variety of settings, including rural Alaska. I don't think that they have really efficient ways to recycle. I think a lot of that material goes out and then probably stays out with nowhere for it to go because it's so expensive to then ship it back. So the goal would be that the materials are already here in Alaska. We need to break them down, repurpose them into something else. So that's the basic concept of what this is. Next slide, please. So what product would you create? I mean, really, it's kind of limitless as to what you could produce from these, but what I want to focus on is food security. I know that one of our organizations that I work with submitted a grant application to the State of Alaska Division of Agriculture. There were 2,500 applications that they're still sorting through, which to me shows me that there's a real strong want to have food security. And so I think that creating a product that would ultimately grow food is a good direction. Next slide, please. This talks about the air gap and the 30 millimeters, and really getting people to connect with their food, I think, is a good way to move forward. And I think that the pandemic really expressed that we only have a week or 2 of food in Alaska, and we also have 20 hours of sunlight, and we need to be utilizing that to the best of the ability that we can, and growing as much food here as possible in people's own back door. Next slide, please. So the goal of this project would be to create a geodesic dome with the air gap and another regular geodesic dome without an air gap, and then test your growing season, if it's extending, monitor the temperatures in there and see if there's a difference, kind of keeping track of it as an experiment, and then publish that information on a website. Next slide. And basically to inspire others to create new products, grow more food, and reduce carbon and waste. Thank you very much.
All right, thank you so much, Crystal. We're now going to move to the judges to see what questions they have. I believe we are going to start with Jim, John, and Reggie.
Hello, so I had a quick question. So it looks like on the presentation, you're building like the connectors and then possibly the rods for the geodesic dome. Are you also looking at trying to do the panels as part of this, or is it just those connectors? That's kind of what I got from what I saw.
So in Girdwood, we are in a rainforest, right? And wood rots. So I would like to use the beams also be plastic, connectors plastic. I want to use as much plastic as possible to create it. And then also the bottom panels and also panels on the north side would be sheet plastic made from like these panels that were shown. And then I'm hoping that we will not have sneeze shields forever, and there will be a lot of plexiglass that will be not used anymore. And so I'm hoping to be able to recycle some of that plexiglass as it comes down inside stores and offices, that we would be able to use that as the kind of windows of the dome. So as much plastic as possible, going to try to incorporate into the domes.
Okay. And then, so I've noticed plastic recycling, it always seems that they have certain plastics that go with certain things. And are you looking to use a certain type of plastic? Can you just mix everything all in and grind it all up and put it in these forms? What's the plan on that?
No, it has to be sorted, and what we're going to do is use the ones that are easiest to work with, and also the safest ones to work with. And then we have a volunteer that transports them to the Dowling Recycling Center, the rest that we're not able to utilize. So obviously it's a small scale project. We wouldn't be able to handle everything that might come in. So we do have to use the resources that are available now, but yeah.
So I just had two quick questions. One is about, if you were to make the entire thing out of plastic like you're hoping to, about how much recycled plastic does that take? And the second question is, what are the size constraints on how big or small these can be based on the structural integrity of the recycled plastic?
Quite a bit. It takes quite a bit of plastic, and precious plastic does have models that break down how much you need for these beams. We're gonna start collecting and breaking it down into it gets chipped in a shredder. And then once we have enough, we will then move to making beams. And that's of course going to be trial and error to come out with the smoothest beam. And then of course the right durability for what's going to withstand our snow loads, etc. But as far as scaling it up, I mean, a geodesic dome can go, if you keep adding a bottom layer on there, you can go up and up pretty high. And so I think we can infinitely scale them small for somebody's backyard, but also maybe scale it up for a community garden project.
Thank you.
Crystal, I think it's a really good idea. I like the scalability of it. Great use of plastic. I think you answered some of my questions that I had initially. I was thinking, were you making the panel? Was it a one-piece deal or whatever? But I see now how it's going. It's really Jim asked all my questions and now I'm just killing time. Sorry. So I will open this up to all the judges.
Let's go ahead and see some digital hands and real hands. The first one I see is Catherine Dodge. So Catherine, you're up first.
Thank you. So Crystal, tell me a little bit, or when I'm thinking about, it seems like part of what you're trying to do is also really make this available to other communities. You want not just to have it in Girdwood, but you want to model it so others can adopt it. Is that correct?
Yes, the machines themselves are pretty inexpensive to build. In fact, with the $10,000 prize, you could build 4 machines with that. Since I already have, I'm sorry?
The recycling, the machine that chips and.
Correct.
Okay, that was my question. So it's fairly easy to build it and.
Yes.
The communities easily adopt that.
Yep, we've hired an engineer to build them locally so that if there's an issue with it, they'll know how to service the machine. And we want to be able to create a model so that this can be replicated in other places. We might want to create a product and then sell that product, but they could do that too. It's just about getting it operational here in Alaska as it has been around the world.
And so when you think about your double-sided, are you thinking, I saw that your picture showed kind of white tubes connecting things. Are you thinking about a sheet on one side of that tube and then a sheet on the other side of that tube? Or have you, or you were talking about beams, is that?
Yeah, so it would be beams, beams with, a sheet on one side and a sheet on the other, exactly.
So just a narrow 30.
30 millimeter gap to get that extra insulation. And then I would like to try experimenting with a space heater to how high we can keep the temperature, how late into the season.
Thank you.
All right, we have time for another question. Do we have one more question for Crystal? All right, Kathleen, you are up.
Crystal, this is interesting. So the pictures that you showed of the domes, were those things that you had created, or those what you hope to create?
More of what I hope to create. One of the domes was actually the precious plastic one, which had the mix of the plastic and the wood. But the ones that I'm hoping to create haven't been created yet.
Got it. Great vision.
Thank you.
And Catherine Dodge, you're going to wrap us up with your last question?
I was going to ask Kathleen's question. What are your next steps?
Well, we got the nonprofit got a Connex delivered by Matson, or I mean not delivered, but donated by Matson shipping. So once the heater runs out, then the Connex is no longer good. So they donate them, and so we're getting one to use as the workspace. What I would do with the prize money is invest in a sheet press machine. So I would probably donate it to the nonprofit, and then invest in the materials that I'll need to create the dome.
Super, thank you.
All right, thank you, Crystal and judges. Before our last presenter of the night, we welcome you to our last sponsor spotlight. The Arctic Innovation Competition awards over $40,000 in cash prizes and awards. This cannot happen without the generous support of many sponsors. All of the AIC sponsors are listed on the website. We wanted to give a special thanks to our presenting sponsor, UAF Coal Mine, as well as supporting the Cubs and Junior divisions are Kinross Fort Knox and Alaska 529. Joining us as new sponsors this year, we welcome GCI and Mount McKinley Bank. And founding sponsors have supported AIC in our mission of innovation and economic development since 2009. That list includes North Rim Bank, Design Alaska, Fairbanks Economic Development Corporation, and Juneau Economic Development Council. Additional support is provided by PDC Engineers and Chris Marock Allstate Insurance, who supports the Fan Favorite Award. Fan Favorite voting offers the public a chance to vote on their favorite idea in each division. Fan Favorite recipients will receive $100 and a unique Lego trophy. Fan Favorite winning ideas in the Cub and Junior divisions will also receive $2,000 towards an Alaska 529 education account. Cast your votes for each division before midnight tonight. All right, just give us one moment while we pull in our last competitor. All right, so joining us as our last competitor for this evening is Tamira Tilakarantha, so sorry, showcasing his idea, small-scale barley threshing and winnowing machine. Can you see your slides?
Yes, I can see.
Perfect. All right. Just remember to watch the 5-minute countdown clock and give us a thumbs up when you're ready.
So the countdown clock is available when I start, right? Is that correct?
Yep. Yeah, it'll show up when you're ready.
Right, I'm ready. Hi, my name is Timira Tilakaratna, and I'm a graduate student of UAF studying electrical engineering. My invention is a small-scale machine that thresh and winnow barley. Next slide, please. Just over a year ago, COVID hit, and I lost my housing on campus and had the fortunate circumstance of being hosted for the summer by former UF Professor Paul Reichert and his wife Terry. They have a large garden where they produce the majority of the food they eat each winter. And I spent the summer helping them in their garden, among other things. I saw that they were putting a lot of effort into threshing the barley they harvested summer before. They would put the barley on a screen and rub it until the grain separate from the chaff. Then the chaff would be blown away or winnowed using an electric fan. This is very tired and time-consuming task. So Terry has been searching for a small-scale thresher for years, and she has really not been able to find anything that meets her needs. When she learned that I'm an inventor because I have done a couple of inventions, she asked me to build a machine to thresh and winnow barley that she grows. Next slide, please. So I was trying different techniques and finally came up with this prototype device. With this, I threshed a couple of pounds of barley for Terry. The hulls were completely removed, and she was very pleased with the quality of the grain with no damage. Next slide, please. So commercially available threshers weigh hundreds or thousands of pounds and cost thousands of dollars. I've been unable to find a small-scale threshing machine for sale. For home gardener, the device that I have developed is perfect. Next slide, please. So I have already built this prototype and tested it by threshing and winnowing a couple of pounds of barley. I made this using yogurt cups and salvaged motors from electric devices and computer fans. Terry is a master gardener who puts on an annual gardening course for about 100 students. Her mission is to encourage individuals to grow a significant amount of their food, thereby increasing Alaskan food security and decreasing emissions and energy use for shipping foods to the state. So my next step is to build a large capacity heavy duty machine for Terry for her personal use and to present it to her gardening class, as she has multiple students interested growing barley. She promotes growing barley as a sustainable and nutritious source of protein. Local interest in growing barley has been limited without access to an efficient way to thresh the grains. This thresher promotes local gardeners to grow grains like sunshine barley developed at UAF in Alaska. So I was able to get feedback from Phil Caspary through Terry. He's the agriculture specialist of Cooperative Extension Service in Delta Junction. He was really excited about this device, especially if this device could thresh other grains such as wheat and rye, which are grown in Delta Junction. As a next step, I'm going to test this device for other grains as well. Next slide, please. I think the side. Yeah, thank you. Home gardeners can't process the grains economically, and that's the reason they do not grow grains. This machine produces perfect grain ready for cooking. The concept is proven. My threshing device removes a significant impediment for home gardeners to grow and eat locally grown grains. This device could be used throughout the US or anywhere in the world where people need an affordable and lightweight machine to process the grain. Thank you.
All right, thank you so much, Tamira. Are you ready for questions from our judges?
I am.
All right, so we're gonna start off with Catherine, Brian, and Jack.
Hi, Samara. So interesting. I know that with the crushing garlic has been a goal, especially as you say in Delta, for a long time. And I'm curious about, and I don't even know how, I don't know how I would understand anyway, but how many pounds can you thresh with this? And do you think it's scalable? Do you think?
Oh, yes. So this is just a prototype. With this device, I was able to process barley, like the final product, 1 pound. It would take about 20 to 30 minutes, depending on the what kind of material that we putting. Definitely this is scalable, and I want to scale up this for a little bit, because this is as I said, this is I made this using plastic cups, yogurt cups, and stuffs. So my goal is to build, like, if we can process grains like 10 pounds per half an hour or up within hour.
And that's pounds of like raw barley in.
Right.
And how much output do you get for 1 pound in? A cup or
So the barley, this should be really dry that we put in, and I would say we'll get about little more than half
out. Yes. And can you, when I meant scalable, I meant really, can you, like, yeah, I think you said it, 10 pound in, half out. You think you can make it a little bit bigger so that it's still farm sized, but more efficient, or can process more.
Right. And I don't want to build a huge device, because the purpose is the small device which can handle. And this one is not weight more than 3 pounds. This weight about 3 pounds, and it's really lightweight. And if I'm gonna scale, it's definitely should be less than 20 pounds.
Thank you.
Thank you. Sounds like a magical device. So I have two questions. I think, is there a manual version that's feasible for this, would that defeat the purpose of the miniature device? And then the second question is, it sounds like a labor-saving device. I don't know the whole process of barley to, from farm to, being able to use the barley. What part of the process does this address in the processing of barley?
So for the first question, this is so there are machines for the large scale, yes, and there are a lot of patents for those kind of machines, and I haven't found any small machine like manual or something that to thresh barley. And for the second question, so after you harvesting barley, if it's dried enough, then you can put those barley to this machine, and then you can turn on the electricity, and it will give you the perfectly threshed and winnowed barley. You can just use it for cooking or something like that.
So to understand, so it's 100% of the process after the barley is dried.
Right.
Well, thank you.
So how much barley does a family like the Reicherts grow in a year?
So they grow about, so last summer I threshed about 6 or 8 pounds. So that's all the barley they grow.
Oh. And so something very small scale is what a family would need, all they would need. Something, is it any bigger than what you have already, or?
The only problem with this is the feeding mechanism is a little bit small. So if it's going to be a little bit bigger feeding mechanism, if I develop it to a little bit bigger feeding mechanism, it would save more time.
So, and what actually happens inside this machine? What is it? What is the machine doing?
So there's a spindle and there's a string attached to that spindle. So when it's rotating, it will separate the grains. And there's another specially designed notch in this cup, and it will that also used to separate the grains, and through that, the separated grains and the other stuff fall into this part, and then it will come through, and it will go through airflow, and then the threshed and winnowed barley, you can collect it underneath.
And so this string is kind of beating it,
right?
Kind of
That's
beats
right.
it, okay. But it doesn't harm the kernel at all.
Not at all. Yeah, because it's, I think it's because of the plastic and it's really flexible, and because of that, I think it doesn't harm for the barley grain at all.
Thank you. That's all I have.
Catherine Dodge, with your hand up, what is your question? And probably the last question.
I was curious, I didn't hear, did you say they had 8 pounds of barley?
That's right.
And did they say to you, now that we have an efficient way to thresh it, we'll grow more or not? Are they still going to grow 8 pounds?
They're still going to grow 8 pounds because that's their annual consumption during the, so and they were really happy, and because I did thresh all the barley for them using this machine.
Thank you.
All right, thank you, judges and Tamira. We are going to pull all of our competitors back into the Zoom panelist mode. So just give us one quick moment. All right, looks like we're all back. So thank you to all of the main division competitors. It is a big deal to make it to the AIC semifinals. We appreciate all the hard work and creativity you've put into your ideas, plus all of you did a fabulous job presenting your ideas tonight. All of the semifinal sessions, including tonight, have been recorded and will be found on the AIC website. After a quick break, the judges will deliberate and make their choices on 1st through 4th place. Honorable mentions and the Arctic, COVID, and Alaska student kickers. Judges, please remember to exit from this webinar and use the new link for your deliberation meeting. Competitors, you will be notified tomorrow morning by an email and follow-up phone call of your placement. Some of you will return for the finals and award ceremony on Saturday with a check-in at 12:30 p.m. Remember, regardless of where you place, there's a chance for any of the ideas presented tonight to win the Fan Favorite Lego Award. There's also a better picture on the website, and $100. Please tell your friends and family to cast their vote on the AAC website before midnight. And thank you, judges, competitors, and our audience. Tune in on Saturday from 1 to 2:30 p.m. for the AIC Finals and Award Ceremony presented by UAF Coal Mine. Watch and see presentations in Cub, Junior, and Main divisions. Fan favorites, kickers, and placements will be announced, including the $10,000 winner. All right, thank you. Have a good night.